Yo guys, it's me back with another video, and today we have a sort of a interesting thing. A CSGO question came in a mathematics paper in Vietnam. It's interesting because we don't really see video game questions being published by professors on their test bank. This was an interesting question which came in an exam, and I thought of sharing with you guys. Even though I mostly make Valorant content, I feel like this is a really nice story. I mean, who knows? Next thing we're going to see Valorant, Rainbow Six, and all the other games questions coming up in the exams. That would be quite interesting to see. Well, in this video, I'm just going to discuss the question paper and the mathematics behind the answers. Basically, the question is this: a player is holding a Desert Eagle and facing an enemy. If a shot is accurate, there is a 20% chance of a headshot which will kill the target immediately. Otherwise, it takes 3 shots to kill. What is the probability that the player takes down the enemy in 7 shots? Interesting probability question which involves a slightly touch of CSGO. It kind of gives a smile for the person solving this question, I'm pretty sure, if it's a CSGO or at least a gamer. Well, the solution is quite easy, but the options that provided were not matching the solution, and most of the community agrees that this solution must be the accurate solution. Either way, even I have learned statistics in my past, especially in my university, so I think this solution is the most accurate. The solution is as follows. We know that the probability to miss a shot is 50%, so that is equal to 1 by 2. We also know that out of those 50% shots that hit, 80% of them hit to the body and 20% of them hit to the head. The probability to hit a body shot would be 80% of that 50%, which is equal to 40%, which is also equal to 2 by 5. Similarly, probability that a shot that has hit is a headshot would be 20% of the 50%, which is 10%. Now the experiment is the player should be taking down the enemy in 7 shots. What's the odds that the player takes down the enemy? We know from the property of probability that in an experiment, the sum of all the probabilities will be 1. So in this specific experiment, the enemy either kills him or doesn't. The probability of the player taking down the enemy in 7 shots plus the probability of player not taking down the enemy in 7 shots will be equal to 1. And now using that, you can say that probability of knocking down in 7 shots would be equal to 1 minus probability of not knocking in 7 shots. And probability of knocking in 7 shots is what we need. Well, why are we doing it like this? Why aren't we directly calculating the probabilities of each specific outcomes, you ask? Well, it's just that it's easier to do this way because there are less number of outcomes that you get from probability of not knocking. Less number of cases, I mean. While in probability of knocking has several cases that you might have to consider, and the calculations should be a bit big. So doing this way, let's find what is the probability of not knocking in 7 shots. The outcome that player doesn't kill the enemy in 7 shots. There are 3 different possibilities. These 3 different possibilities are the only way the person would not be able to knock the enemy down. The first way is that the enemy misses all the 7 shots, and there is only one permutation for it. Basically, all he misses, or she. The second way would be for the person to hit one body shot and miss all the other 6 shots. This can be conducted in 7 ways. Essentially, he either hits the body shot in the first shot, or the second shot, or the third shot, and so on up to 7. So there are 7 different ways to do this specific option. The third and last way that he misses the knockdown would be to hit the enemy 2 times to the body. This can be done in 21 ways. This is a simple formula for it. And if you want to count all the ways you can do it, it will give you 21 ways. You can basically arrange 21 different ways. So like he hits the enemy in the first and second shot, first and third shot, first and fourth, second and third, and all those combinations that you get, they will essentially add up to 21. There won't be any more cases because if the person hits the enemy in 3 shots, it's a knockdown. If it's a headshot, it's a knockdown. So these 3 are the only possibilities of him not able to knock down the enemy. So all we need to do is sum all the probabilities of these individual options. That's the probability of probability. Probability of the first option, which is missing all 7 shots, would basically be 50% multiplied 7 times. So 50 power of 7, or 1 by 2 power of 7. Why is it 1 by 2 power of 7? Basically, it's another property that if you're able to do a specific work in n times and another specific work in m times, the total ways to do the works together would be m times n, and the probability follows the same way. If the probability of A is P of A and B is P of B, probability of both of them together will be P of A times P of B. Only if A and B are I don't exactly remember what do we call it, mutually exclusive or mutually exhaustive. I don't really remember it. It's just a long time ago. So I'm pretty sure it's following the probability. So you multiply 1 by 2 7 times, so that's 1 by 2 power 7. The second probability would be 7 times probability of hitting the shot once and probability of missing the shot 6 times. So that is 7 times 2 by 5 times 1 by 2 power 6. The third possibility, which is hitting 2 body shots and missing all of them. So hitting the body shots 2 times would be 2 by 5 whole power of 2, and missing them 5 times would become 1 by 2 power of 5 and multiplied by 21 different possible ways. Now if you add all of them up, you will get 0.15656, and if you subtract this from 1, you will get 0.84344. Multiplying this by 100, it means the odds of the person knocking down the enemy would be 84.34%. But this option is not available in the options of the paper. So what's going on here? Basically, everybody is sure that this math is correct, and the only way the professor was wrong is because he missed one specific scenario. If you miss all of the 7 shots, the probability is 0.008781, right? If you add that to 0.84344, you will get 0.85125, and this is that's 85.125%. And that's the option which is available in the question paper. So the professor probably missed the first case that the enemy misses all 7 shots. So I think he considered that a shot has to be fired. So I'm not sure, maybe the translation is lost, or maybe so yeah, it's an interesting way to introduce video games to mathematics. I just wanted to share it with you guys. Even though you're not a CSGO player, this is quite interesting to see. In the future, we might have more questions from which are inspired from video games. That would be interesting to see how video games and mathematics and other subjects are able to be combined. See you guys later. I hope you found this video interesting. Let me know your thoughts in the comments. See you guys later. Peace.